Hello everyone, welcome to our fourth lecture on gravitation, and in this lecture we are going to discuss about motion of a particle under gravity, and we will discuss about weight. So starting our video, uh, you must be familiar with three equations of motion. First is v equal to u plus at. Second is s equals to ut plus half a t square, and third one is v square minus u square equal to 2as. Now we have to write these equations of motion when particle is uh, like uh, traveling vertically from against the gravity or in the direction of gravity. So I am writing for first for free fall. For free fall means particle is undergoing motion in uh, vertical direction towards the center of Earth. So for that we have to take a as plus d, because in that case if particle is freely falling, the only acceleration or the only force acting on the particle is because of gravitational field of Earth. So we can write acceleration as positive g. Why positive? Because particle is undergoing acceleration. Suppose I am dropping this marker from this position, so it is at rest, and then its velocity increases and it is going towards the center of Earth. So we will take acceleration as positive g. Now change these equations for free fall. I can write first equation of motion as v equals to u plus gt. Second is in free fall or motion of a particle under gravity, we will take as h. Why h? Because we are dealing with height. The displacement we are dealing with is will be height, because we are uh, dealing with vertical motion. So in that case we can write displacement as height. So I can write second equation as h equal to ut plus half gt square. This is not the free fall. You can write this as motion of particle, downward motion of particle, downward motion of particle under gravity, under gravity. And third equation I can write as v square minus u square equal to 2gh. Now we will see upward motion of particle against the gravity. Why against the gravity? Suppose you are throwing something in upward direction and gravity will act in downward direction. So gravity is trying to take this marker in downward direction, but it is going upward. So gravity or gravitational force is resisting its upward motion. That's why I'm writing against the gravity. So when you throw something upward, its velocity decreases. Its velocity going to decrease, and suppose you throw this with 20 meter per second. You throw a ball with speed 20 meter per second in upward direction, so it will go to, as it go, its velocity keeps decreasing continuously, and at some height its velocity will be 0, and at that height it will be in rest, and then it starts falling in downward direction. Suppose I am throwing this marker up it goes to its maximum height, then it started downward motion. Similarly here, it can go to its maximum height, like this is its maximum height, then it starts downward motion. So at maximum height, final velocity of the particle is 0. That's why particle stopped at that position. So remember that when you will solve the questions, you have to remember this thing, that at maximum height of a particle undergoing upward motion, at maximum height its final velocity will be 0. So we can write equation of motion. First equation of motion will be, you have to take acceleration as minus g. In this case, motion of a particle under gravity in downward direction, particle is accelerating, and but when particle is going upward, it is deaccelerating. It is going against the gravity and it is deaccelerating. So we have to take g as minus g. So I can write first equation of motion as v equals to u minus gt minus, and second is s, not s, I can write this as h equals to ut minus half gt square, and third equation will be v square minus u square equals to minus 2gh. Now we will take some numerical problems on this topic. First question is, stone is dropped freely in a river from a bridge. Stone is dropped freely in river from the bridge. Stone takes 2 seconds. Stone takes 2 seconds to touch the water surface. Touch the water surface in river. Calculate height of bridge from the water. Calculate height of bridge from water level. Suppose this is river and this is the bridge. You are dropping a stone from this position and it takes 2 seconds to reach the water surface in the river. Time is 2 seconds. You have to find this height h. We can use second equation of motion. This for this we can use second equation of motion, h equal to ut plus half gt square. Why positive g? Because particle is going in the direction of gravity. As particle is dropped from some height, drop means it has no initial velocity, u equal to 0. So I can write this h equals to half g t square. Half g is 9.8, time is 2 square 4. This is 19.6 meter. So the height of bridge from the surface of river is 19.6 meter. We will take few more questions. A cricket ball dropped from 20-meter height. A cricket ball dropped from 20-meter height. Calculate speed of ball. When it hits the ground. Just before when it hits the ground. And in part B, you have to find calculate time it take to fall through this height. A cricket ball is dropped from 20-meter height, and you have to take G as 10 meter per second square in this case. You can take G as 10 when it is given in the question. If this is not mentioned the value of G in the question, you have to always choose G as 9.8. But if it is given in question that you can take G as 10 meter per second square, then you can take. A particle is dropped from 20-meter height, then H is 20 meter. You have to find calculate speed of the ball when it hits the ground. You have to find velocity just before it hits the ground, and it is dropped means initial velocity is 0. So we can use third equation of motion, v square minus u square equal to 2gh. This term is 0, so I can write h as v square by 2g. Height will be v square means no, we have to find v. We have to find v, not height. Height is given, so v square equal to 2 into 10, and height is 20. This will be 2 into 10, 20, 20, 400. Take square root both sides. So v equal to 20 meter per second. So the speed of ball when it is about to hit the ground, then the speed of ball will be 20 meter per second. In part V, we have to calculate time it take to fall through this height. We have to find time. To calculate time, we can use first equation of motion. V equals to u plus gt. U is 0. So v equals to gt and t equals to v by g. V is 20, g is 10, time equals to 2 seconds. Next question. A ball is thrown vertically upward. Vertically upward with speed speed 49 meter per second. You have to find in part A speed after 3 seconds. Speed after 3 seconds. V part you have to find maximum height of ball. Maximum height it can reach. A ball is thrown vertically upward with initial velocity 49 meter per second. It will undergo deceleration because it is going against the gravity. So acceleration equals to minus d, and you have to find speed after 3 seconds. In part A, you have to find speed. So I can write first equation of motion, v equals to u minus gt. t equals to 3 seconds. We have to find speed after 3 seconds. So u is 49 minus g 9.8 into 3. This will be 49 and 29.4. This will be 19.6 meter per second. It is initially thrown with 49 meter per second. Means you throw the ball with 49 meter per second in upward direction, but after 3 seconds its speed becomes 19.6 meter per second. That means its speed keep reducing continuously. That's why I'm saying that it is undergoing deceleration. In part B, you have to calculate maximum height of the ball. I just told you that at maximum height, when you throw something upward, at maximum height its final velocity will be 0. V equals to 0. U is 49. We have to find height. I can use third equation of motion. V square minus u square equals to minus 2gh. This will be 0 at maximum height. Minus to minus cancel out. So u square equals to 2gh. I can write h equal to u square by 2g. U square is 49 into 49, 2 into 9.8. This will be 5 times, and this is 49 to 45 by 2. So height is 122.5 meters. You have to remember just these things and you can solve the questions very easily. Now we will discuss about mass and weight. So what is mass? Mass is basically amount of matter contained in a body. So everything is made up of atoms and every atom has finite atomic mass. So depends on that thing. Mass of every quantity gives information about the matter contained in a body, and it is indestructible. Means mass can never be created nor be destroyed. It will for a finite body it will always be same. If you are not cutting the body, not damaging the body, its mass will always be same. Suppose if you burn a paper, it will convert into S and water vapor and carbon dioxide. And if you measure mass of the paper before burning and after burning, if you take mass of S's and plus that carbon dioxide which is produced during its burning and water vapor, if you take mass of these three things, it will come out equal to mass of paper. That means mass is always constant, means it cannot be destroyed, and it is a fundamental property of body, as I told you, and it does not depend on shape and size. uh, it does not depends on shape and size. Means if you are taking 1 kg iron and 1 kg of cotton, 1 kg of iron, like this much box will contain 1 kilogram mass of iron, and if you are taking 1 kg of cotton, its mass will be like this much huge. Its shape will be this much huge. That means it does not depends on shape and size. If particle is dense, means its atoms are arranged very closely, then it will have more mass in less shape. And if a particle's atoms are arranged very far, then its mass will be less in less surface area, or you can say less shape. And as I told you, mass is indestructible and mass is independent of location. It means that uh, if a mass of a body is say 50 kilogram here, then its mass will be 50 kilogram on moon, on Jupiter, on Mars. Everywhere its mass will be same. Mass is not going to change. The only thing that is going to change is weight, because weight is the force, not the amount of matter contained in a body. So weight can change, but mass can never be changed. And it is a scalar quantity. That means it's only a magnitude. So mass is a number only. It has no direction. It is just a number. Now we will discuss about weight. So what is weight? Weight is the force with which Earth or any other planet, suppose you are at Moon, then what force, with what force Moon is attracting you towards its center, this is called weight. So if you are dropping a ball and it will go, it will move in downward direction towards the surface of Earth, and that force with which it is attracted by Earth towards its center is weight. And weight is a vector quantity. That means it has magnitude and it also has direction, and its direction is always towards the center of Earth. And if you are on another planet, then towards that planet's center. And as you know, weight can be written as mass into g. And as you know, mass is a constant quantity. Mass is not going to change anywhere. So what we did in previous videos, we can write, if we have a directly proportional symbol, we can replace that directly proportional symbol with equal to symbol, and we have to put one uh, constant quantity. But if we have a constant quantity and equal to symbol, we can write that equation as directly proportional equation, means weight is directly proportional to g. In previous videos, we discussed how acceleration due to gravity change with height, with mass of the planet, with radius of the planet, and how it change when you are going in some depth of a planet, how it is changing. In similar way, that weight of a body will also change because it is directly proportional to g, and it will change according to the g. As g is changing, weight is also changing. So everything will remain same as you did for the g. Everything will change in same manner. Now suppose acceleration due to gravity on moon is 1.6, it's around 1.6 meter per second square, and g at earth is 9.8 meter per second square. So if you are taking a body of mass 100 kg, its weight on moon will be 160 newton, and weight on earth will be 980 newton. This much difference uh, in the weights, or you can say in the force exerted by moon and earth on a body. So when you measure your mass or weight using a weighing machine, so what it gives you, suppose you are standing on a weight measuring machine, it has a meter here, this shows reading here. So what thing it shows you, suppose you are standing on that machine, so earth will attract you towards its center, and that force will be your mass time gravity. You are attracted towards the center of earth with this force. And as I told you that from Newton's third law, everything applies, everything gives equal and opposite reaction. So this surface of this weighing machine will apply opposite force on that human in upward direction. So this machine just shows how much force this machine is applying on the human in response to weight of the human. And weight means the force uh, applied by the center of earth or earth on this human. So gravity on earth. So acceleration due to gravity on moon is 1/6 of g on earth. For that, mass of moon is mass of earth is 100 times than mass of moon. Mass of earth is 100 times more than mass of moon, and radius of earth is 4 times radius of moon. So as you know, G is written as G mass of planet upon radius of planet square. If I have to find weight is on this one. We have to find weight on moon, weight on earth. These things will change or vary in similar manner as I told you. So weight is mass into G. So I can write weight will be G m upon r square. So find for moon, weight on moon will be G into mass of moon into mass of any body for which we are finding weight, and r of moon square. Now weight of body on earth will be G. I can write mass of earth as 100 into mass of moon into mass of the body for which we are finding weight. And I can write radius of earth as 4 into radius of moon. Suppose this is equation 1, this is equation 2, and take this thing, second equation. I can write weight of earth as, I'm taking 100 this side and writing G into mass of moon into mass of the particle upon this square, means 16 into radius of moon square. So I'm taking 16 this side and writing radius of moon square this side. So you can see this quantity is weight of moon. This is around 1.6, 1 by 6, and this is weight of moon. So from here it is clear that weight of earth is means weight of moon is 1 by 6th of weight of a body on earth. Now we will take some numericals on this topic. So we will solve these questions. First question is find weight of a 10 kg body on surface of earth. As you know, weight is equal to mass of a body into acceleration due to gravity at that point. So mass is given as 10 kg and acceleration due to gravity at surface of earth, we know it is 9.8. So weight of a 10 kg body on surface of earth will be 98 Newton. Move to second question. Find mass of a body whose weight on surface of moon is 320 Newton. Means weight is given 320 Newton. We have to find mass, and G at surface of moon is 1.6 meter per second square. So as you know, W equal to mg. So m equal to W by g. W means weight is 320 and acceleration due to gravity on moon 1.6. So this will be 16 to the 32 200. So mass is 200 kg. Now third question, find the weight of a body of mass 10 kg which is at a height equal to radius of earth above the surface of earth. So suppose this is earth and its radius is r, and we don't have to find the weight of a body here, we have to find the weight of the body, and which is this distance. This is radius of earth and it is twice the distance radius of earth from the center of earth, means one radius of earth distance this and one radius of earth distance this, and here is the particle. We have to find weight of that body at this position, at this position. Now weight weight is m into g, and we know that variation in acceleration due to gravity with height. Formula was g dash equals to g r upon r plus h whole square. Here h is given as r, height is also radius of earth. This height is height of the particle from the surface of earth. So from the surface of earth, height of the particle is equal to radius of earth. So I can write height equal to r. So from here g prime equal to g r upon r plus r, 2r square. So g prime equal to g 1 by 2 square means 1 by 4 gy 4. This will be 9.8 upon 4. So this will be, put g prime here, w prime equals to mass is 10 into 9.8 by 4, 5, 2. This will be 4.9. So weight of that body is 49. Half of 49 is 44.5. So weight of that body is at the height equal to radius of earth is 24.5 newtons. So this chapter is completed and we will start next chapter, work, energy and power, in next videos. Thank you for watching.